Hello GATE aspirants. Welcome to part 5 of GATE Mathematical Physics series. Question 1. The unit vector perpendicular to the surface x square plus y square plus z square is equal to 3 at point 111 is. Now the function is x square plus y square plus z square minus 3. Let us find out its gradient. So that is 2x x cap plus 2y y cap plus 2z z cap. At point 111 it will be 2x cap plus 2y cap plus 2z cap. Its magnitude will be under root 2 square plus 2 square plus 2 square, so that is 4 into 3 and it is 2 root 3. So the unit vector perpendicular to the surface is del phi upon magnitude of del phi, which is 2x cap plus 2y cap plus 2z cap upon 2 root 3. Taking 2 common, this will be x cap plus y cap plus z cap upon root 3. So option D is correct. The matrix A is equal to 1 by root 3, 1 upon 1 minus I, 1 plus I minus 1 is orthogonal, symmetric, antisymmetric, unitary. Now the matrix is said to be symmetric, antisymmetric or orthogonal when the matrix is real. So here the matrix itself is not having real values. Let us check for fourth one. Let us find out its complex conjugate. So it will be 1 by root 3. You have to take transpose and also complex conjugate. So this elements, diagonal elements will be same. So here we will have 1 minus I and minus I will become plus I. So 1 plus I here and here 1 plus I and it will be minus I. So now A into A Hermitian. This has to be identity matrix, then it will be unitary. So let us check. We have 1 plus I, 1 minus I minus 1 into 1 plus I, 1 minus I minus 1 into we have 1 by root 3 into 1 by root 3. So that is 1 by 3. So 1 by 3 into 1 into 1, 1 plus I into 1 minus I. So that is 1 square plus minus of I square. So this will be 1 plus 1 plus 1. Then we have 1 plus I minus 1 into 1 plus I. Then 1 minus I, then minus 1 into 1 minus I. And here again 1 plus I into 1 minus I, so that is 1 plus 1 and minus 1 square. So that is also 1. So this will be 1 by 3 into 3. This will be 0, 0 and 3. So this is 1, 0, 0, 1, which is an identity matrix. And these two matrices are same matrices only. So this is also equal to A Hermitian into A. A dagger into A. So this is unitary matrix. So option D is correct. The length of element ds of an arc given by, we have ds square is equal to 2 dx1 square plus 2 dx2 square plus root 3 dx1 dx2. The metric tensor Gi is. Now ds square is, this is written like this, Gij, then we have dxi and here we have dxj. So this will be equal to G11 dx1 square plus G22 dx2 square plus 2G12 into dx1 dx2. And we have G12 is equal to G21. So by comparison, here we have G11. So G11 is equal to 2. Then G22 is equal to 1. And then G21. This is root 3, right? So this will be root 3 by 2. And G12 will be root 3 by 2. So this diagonal elements will be 2, 1. So here we are getting 2, 1 and 2, 1. So divided by 2, but in the option, it is, this root should be here, root 3 by 2 should be there. So option B is the closed one. Next, the value of integral z square upon e raised to z plus 1 dz, where C is the circle, z is equal to 4. So it is a circle at origin with radius equal to 4. and this is the function. Now let us find out singular points. For singular points, we have e raised to z plus 1 is equal to 0. So e raised to z is minus 1, which can be written as e raised to I 2n minus 1 pi. That means z is equal to I into 2n minus 1 into pi. So this can be plus minus I pi or plus minus I 3 pi plus minus I 5 pi and so on. Now we have to consider only those singular points which lie inside the curve. Now pi is 3.142 into 3, it will be 9 point something, so it is outside this curve. So only plus minus I pi lies inside the curve. So let us find out residue at those points. So residue when z is equal to plus minus I pi. So this will be equal to, numerator will be as it is, and we have to take derivative of denominator, which is e raised to z at z is equal to plus minus I pi. So this will be, z is plus minus I pi, its square will be I square into pi square, and into z raised to we have plus minus I pi. So this will be minus pi square upon e raised to plus or minus I pi, it is always equal to minus 1. So this will be pi square. So at both points residue is pi square. Now value of integral is 2 pi I into summation of residue. Now one residue is pi square and another one is also pi square. So this will be 2 pi into 2 pi square. So that is 4 pi cube into I. So option C is correct. Next, the solution of the differential equation d2y by dt square minus y is equal to 0, subject to the boundary conditions y of 0 is 1 and y of infinity is 0 is. Now the function is d square minus 1 y is equal to 0. So d square is equal to 1, d is equal to plus minus 1. So function is equal to y1 e raised to t plus c2 e raised to minus t. Now y of 0 is 1, so that means it is equal to c1 plus c2. And y of infinity is 0, that means c1 e raised to infinity and e raised to minus infinity is 0, that is c2 into 0. Now this means c1 has to be 0, then only this function will be 0. And if c1 is 0, that means c2 is equal to 1. So the function is e raised to minus t. And this can be written as cos hyperbolic t minus sin hyperbolic t, because cos hyperbolic t is e raised to t plus e raised to minus t upon t minus e raised to t minus e raised to t upon t. So this will cancel out and we will get e raised to minus t upon minus minus plus, so 2 into e raised to minus t upon 2, that will be e raised to t. So option D is correct. So these were all the questions from GATE 2014 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.